Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on complex analysis, power series lecture 3, in which I will solve some problems on radius of convergence. Now we solve a problem. Problem is find the radius of convergence of the power series sigma z to the power n by factorial n. Now we solve this. Let R be the radius of convergence of the given power series. We know that 1 by R equal to limit n tends to infinity modulus of a n plus 1 by a n. Here a n equal to 1 by factorial n and a n plus 1 is 1 by factorial n plus 1. Therefore 1 by R equal to limit n tends to infinity modulus of a n plus 1 is 1 by factorial n plus 1 by a n equal to 1 by factorial n. This equal to limit n tends to infinity modulus of 1 by factorial n plus 1 multiply factorial n by 1. This equal to limit n tends to infinity. Here factorial n plus 1, here factorial n. We may write this 1 by n plus 1 multiply factorial n multiply factorial n by 1. This means limit n tends to infinity. Here factorial n and factorial n cancel. 1 by n plus 1. Since n tends to infinity, therefore 1 by n plus 1 equal to 0. Implies that 1 by R equal to 0 implies that R tends to infinity. Means if the radius of convergence be R, then here R is infinity, means radius of convergence is infinity, means the series is convergent, therefore series is convergent for all z. If R would be finite, then the series would be convergent inside this circle of radius R. But here we have R equal to infinity, means we have a circle having radius infinity, means the series is convergent in entire region, means for all z. Now we solve problem number 2. Find the radius of convergence of the power series sigma factorial n by n to the power n multiply z to the power n. Now we solve this. Let R be the radius of convergence of the given power series. We know that 1 by R equal to limit n tends to infinity modulus of a n plus 1 by a n. Here a n equal to factorial n by n to the power n and a n plus 1 equal to factorial n plus 1 by n plus 1 to the power n plus 1. Therefore, 1 by r equal to limit n tends to infinity modulus of a n plus 1 is factorial n plus 1 by n plus 1 to the power n plus 1 by an factorial n by n to the power n, and this is equal to modulus of factorial n plus 1 by n plus 1 to the power n plus 1 multiply n to the power n by factorial n, implies that 1 by r equal to limit n tends to infinity. Here there is no need of this modulus because all are positive quantities. So here we write factorial n plus 1 means n plus 1 multiply factorial n, and this is n to the power n. Here n plus 1 to the power n plus 1 multiply factorial n, implies that 1 by r equal to limit n tends to infinity. Here n plus 1, here n plus 1 to the power n plus 1 means here we get n plus 1 to the power n, 1 power reduced, and factorial n cancel. Here n to the power n, implies that 1 by r equal to limit n tends to infinity. Here we may write this as 1 by n plus 1 by n to the power n, implies that 1 by r equal to limit n tends to infinity 1 by 1 plus 1 by n to the power n, and this is equal to e, 1 by e, implies that r equal to e. So radius of convergence is e. Therefore series is convergent for all those values of z which lies inside the circle with radius e. Now we solve the next problem. Next problem is find the radius of convergence of the power series sigma 2 plus in by 2 to the power n multiply z to the power n. Now we solve this. Solution. Let r be the radius of convergence of the given power series. We know that 1 by r equal to limit n tends to infinity modulus of an to the power 1 by n. Here an equal to 2 plus in by 2 to the power n. Therefore 1 by r equal to limit n tends to infinity modulus of 2 plus in by 2 to the power n whole to the power 1 by n. this equal to limit n tends to infinity modulus of 2 plus in is 2 square means 4 plus n square square root by 2 to the power n modulus whole to the power 1 by n implies that 1 by r equal to limit n tends to infinity. Here we take common n square. N square 1 plus 4 by n square by 2 to the power n whole to the power 1 by n implies that 1 by r equal to limit n tends to infinity. Here we get each term is positive, so there is no need of modulus. We will get n square 1 plus 4 by n square to the power square root means half multiply 1 by n. Here 2 to the power n to the power 1 by n means 2 implies that 1 by r equal to half limit n tends to infinity. Here n square to the power half means n to the power 1 by n. Here 1 plus 4 by n square to the power 1 by 2n. Let this is number 1. Let x equal to n to the power 1 by n implies that log x equal to log n to the power 1 by n implies that log x equal to 1 by n multiply log n. Taking limit n tends to infinity, limit n tends to infinity log x equal to limit n tends to infinity log n by n. By using L'Hospital's rule, we get derivative of log n is 1 by n and derivative of n is 1 using L'Hospital's rule. Here limit n tends to infinity. This is equal to, if n tends to infinity, then 1 by n equal to 0. Here we write base e implies that x equal to e to the power 0. This is 1. Here limit n tends to infinity. Putting the value of x implies that limit n tends to infinity, value of x is n to the power 1 by n and this is equal to 1. This is number 2. Now let y equal to 1 plus 4 by n square to the power 1 by 2n implies that log y equal to log 1 plus 4 by n square to the power 1 by 2n implies that limit n tends to infinity log y equal to limit n tends to infinity 1 by 2n log 1 plus 4 by n square. This is equal to limit n tends to infinity 1 by 2 n log 1 plus 4 by n square is 4 by n square minus 1 by 2 4 by n square whole square plus dot 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 dot. This equal to limit n tends to infinity 1 by 2 4 by n cube minus 1 by 2n 4 by n square whole square plus dot 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 dot. This equal to half limit n tends to infinity. This is 0. Limit n tends to infinity. This term is also 0. So we get 0 and this is 0 implies that limit n tends to infinity. Here base is e. Here y equal to e to the power 0. This is 1. Implies that limit n tends to infinity y means 1 plus 4 by n square to the power 1 by 2n and this is equal to 1. This is number 3. Putting values of 2 and 3 in 1 we get 1 by r equal to half limit n tends to infinity n to the power 1 by n is 1 and limit n tends to infinity 1 plus 4 by n square to the power 1 by 2n. This is also 1. This is equal to half implies that r equal to 2. Therefore, radius of convergence equal to 2. Therefore, the series is convergent inside of the circle whose center is 0 and radius is 2. In each point of the inside of the circle, the series is convergent. Here we may take any point z inside the circle, then we will get that at this point the series is convergent. Now we solve the next problem. Problem is find the radius of convergence of the power series sigma 2 to the power minus n by 1 plus I n square z to the power n. Now we solve this. Let r be the radius of convergence of the given power series. We know that 1 by r equal to limit n tends to infinity modulus of a n to the power 1 by n. Here a n equal to 2 to the power minus n by 1 plus I n square. Therefore, 1 by r equal to limit n tends to infinity 2 to the power minus n by 1 plus I n square modulus 1 by n power, and this will be equal to limit n tends to infinity. Here 2 to the power minus n to the power 1 by n is 2 to the power minus 1, and here modulus of 1 plus I n square equal to 1 plus n to the power 4 square root and to the power 1 by n. This will be equal to, here 2 to the power minus 1 is 1 by 2 limit n tends to infinity. Here 1 by, we take common n to the power 4. Here 1 plus 1 by n to the power 4. Here to the power half. Square root means half. Multiply 1 by n. Implies that 1 by r equal to half limit n tends to infinity 1 by, here n to the power 4, here 1 by 2n, that is n to the power 2 by n, and 1 plus 1 by n to the power 4 to the power 1 by 2n. Similar to previous problem, here we get half, value of this will be 1 and value of this will be also 1. So this is half, implies that r equal to 2. Therefore radius of convergence equal to 2. Therefore the series is convergent for all those points which lies inside of a circle having radius 2, with center be the origin. Now we solve the next problem. Problem is find the radius of convergence of the power series sigma minus 1 to the power n by n under bracket z minus 2i to the power n. Now we solve this. Here center of convergence is z equal to 2i. Generally we write in power series z to the power n, means z minus 0 to the power n. Here z minus 2i to the power n. That means center of convergence is z equal to 2i. Let the radius of convergence be r. Then we know that 1 by r equal to limit n tends to infinity modulus of a n to the power 1 by n. Here a n equal to minus 1 to the power n by n. Therefore 1 by r equal to limit n tends to infinity a n means minus 1 to the power n by n modulus to the power 1 by n, and this is equal to limit n tends to infinity. Here minus 1 to the power n modulus to the power 1 by n. In modulus we get positive quantity 1 by n to the power 1 by n. Since limit n tends to infinity, n to the power 1 by n equal to 1. So this is equal to 1 by 1 means 1, implies that r equal to 1. Therefore radius of convergence equal to 1. Therefore the series is convergent inside a circle whose center is z equal to 2I and radius equal to 1. Here this is circle, here center is z equal to 2I and radius is 1. The series is convergent for all those points lie inside the circle. Therefore our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.